Good morning dear students, myself Dr. Priya working as Associate Professor in Department of Humanities and Sciences, MLR Institute of Technology. So today we are going to discuss about the property of knocking. So generally this property it is exhibited by the fuels that we are going to use for transportation purpose like petrol, diesel will have this property. So actually the good quality fuel should have better anti-knocking properties. Or else if it is not having such kind of anti-knocking properties, it is to be mixed with some kind of additives. Those are called anti-knocking agents. So in today's session, what we are going to discuss about is introduction, what is knocking, that is definition, that is introduction to knocking, and what is anti-knocking property and its introduction part, that is its definition. And then for petrol based ICEs, that is internal combustion engines, how this knocking can be exhibited or how it can be identified. So all these things we will discuss under the heading that is called octane rating. And then for diesel based ICEs, internal combustion engines, we are going to discuss about this knocking and anti-knocking properties in the case of diesel based ICEs, that is under the heading C10 rating. So let us go by introduction part of knocking. So knocking is a kind of property, that is how it is defined, let us see. So due to certain constituents that were present in the fuel, that is sometimes the oxidation of the fuel becomes so great that the last portion of the gasoline along with the air, it is able to produce or generate some kind of unwanted explosive and violent sound, that is what we call it as knocking. So if that fuel sample it is having different kinds of impurities, so then it is able to show its influence on oxidation of the fuel that is going to take place. So what will happen, that last portion of that petrol along with the air, because for combustion reaction to take place, fuel is to air will, mixer will have an important role. So that last portion of the gasoline along with the air, it is able to generate, if it is having some kind of impurities in the fuel, then it is able to generate some kind of unwanted explosive as well as violent sound, that is what we call it as knocking property. So if it is existing for the fuel, then it is able to reduce or decrease the efficiency of the internal combustion engine, and it is also able to damage during its long run. That means if you are not going to avoid the usage of such kind of fuels in long run, it is able to reduce the efficiency of that engine and finally it gets damaged. So if you notice the fuel constituents, what will be this tendency of the fuel constituents to involve a knocking process? So if it is checked or if it is noticed, this will be the order of priority. Straight chain paraffins it is greater than, branched chain paraffins it is greater than, olefins it is greater than, cycloparaffins it is greater than aromatic compounds. Straight chain paraffins means alkanes will come, okay. So and branched chain paraffins means that alkanes which are having a kind of substitution, alkyl substitution on any of the carbons in their skeleton. So and then olefins means doubly bonded, that means alkenes will come. And then cycloparaffins means alkanes which are having cyclic structure, and then finally followed by aromatic compounds. A compound is said to be aromatic in nature if it is having or if it is able to satisfy different conditions, and one among the most important is it has to obey Huckel rule, that is it should contain 4n plus 2 pi electrons, and then it should possess, or whenever it is subjected to burning using one flame, that means it is brought near a flame, it is able to release sooty flame, then only we can say it is example for aromatic one. So this is the order of reference for tendency of the fuel constituents in order to involve in knocking process. So and then next thing it is, as I told you, basing on the fuel that we are using or basing on the ICEs, internal combustion engine, whether it is petrol related or diesel related, this is of two types, octane rating and C10 rating. So this is identified or we can say introduced by Edger, that's why it is named as Edger's octane rating. So that means we are going to assess the anti-knocking behavior of the petrol sample, clear. So we are going to assess the anti-knocking behavior or we can say property of the petrol sample, that is expressed or measured in terms of a parameter that is called octane rating. So let us see the two examples, that is, one is I have considered N-heptane. N represents straight chain linking, that is straight chain paraffin. Heptane, hepta means 7, presence of 7 carbons. If you notice 1, 2, 3, 4, 5, 6, 7. 7 carbons it is having, and N it is representing all the bonds that are present between the carbons are single bonds or sigma bonds, and this is what we call the structure of N-heptane, and it possesses an octane number that is equal to 0. So, it is having an octane number that is equal to 0. And if you notice the second one, so this is what we call the structure of isooctane. Isooctane or 2,2,4 trimethyl pentane. If you notice 1, 2, 3, 4, 5, pent represents presence of 5 carbons, and on the second carbon it is having disubstitution of methyl group, 2 methyl groups were present, and similarly on the fourth carbon it is having one more methyl substitution. That's why it is, according to IUPAC nomenclature, it is named like 2,2,4 trimethyl pentane. Clear? So, it is having a common name that is called isooctane, and it possesses an octane number or octane rating value as 100. So, any compound or any substance which possesses this octane number as high one, that is, when it is present in proper proportions in the fuel sample, then it is able to impart anti-knocking properties to that fuel sample. Okay. So, basing on the two examples, now what is octane number we are going to define. So, basing on the above two examples, just now we discussed that is N-heptane and isooctane. So, octane number of petrol or any petrol based ICE, that is internal combustion engine, it is defined as the percentage of isooctane in a mixture of isooctane and N-heptane. That means, isooctane it is having an octane rating or anti-octane property as 100, and N-heptane it is having 0. If this isooctane it is present more in amount, then that fuel will have better anti-knocking properties. So, it is defined as the percentage of isooctane in a mixture of isooctane and N-heptane, which matches the fuel under test in its knocking properties. So, for example, I am going to consider a fuel with octane number 80. I have considered a fuel with octane number 80. So, what does it mean? A fuel which is having same combustion properties or knocking properties, because I have considered 80, number I told you 80, that means 80:20 mixture I have considered. That means, as I told you, isooctane content should be more, 80:20, that means 80% it is of isooctane is present and remaining 20% it is of N-heptane. So, that is why it possesses an octane number that is 80. So, that fuel will have better anti-knocking properties. So, these are some few anti-knocking agents listed here, which are able to reduce the knocking behavior for the fuel when added like additives. If these were present in more amount and the proper proportions we have to add, then it will have better anti-knocking properties. So, let us see or examine all these examples. So, one is tetraethylate, that is TEL. Tetraethylate can be added as an anti-knocking agent, and diethyl telluride. This is what we call as ethyl group C2H5, and it is present like twice, C2H5 taken twice. These two are attached to tellurium. It is diethyl telluride, and then toluene, ethyl benzene, benzene which is having ethyl substitution, that is C2H5, and then methyl tertiary butyl ester, iron pentacarbonyl, and then ferrocene. So, these are so many examples for better anti-knocking properties. If these were added in proper proportions to the fuel sample, then these are able to impart anti-knocking properties to the fuel that we have considered for ICE, petrol based ICE. Okay. So, let us go with C10 rating or C10 number. So, this C10 number will exist, or it is a kind of measure or a parameter for knowing that anti-knocking properties of diesel based ICEs. diesel based ICEs, C10 number or C10 rating. So in a diesel engine or diesel based ICE, so we have an idea that in diesel based engines, fuel it is not ignited by spark, just like in petrol based ICEs, ignition will be done by electric spark. When ignition it is on for the vehicle, then immediately it gets ignited by an electric spark, so that fuel is able to catch that spark, and then it is involved in various kinds of strokes, and then followed by, that is compression stroke, everything will take place, and then it is subjected to combustion reaction, so that it is able to release heat energy. So this is what is a kind of mechanism that is happening in petrol based ICEs. So in the case of diesel based ICE, if you notice, so fuel is not ignited by that electric spark, just like in petrol based ICE. So but what it will do is, the compression, it is this diesel based ICE, it will ignite itself. How that it will take place means, this is due to purely compression of air, it is getting increased. If this air it is able to compress more, as a result corresponding pressure will be increased. So the compression of air increases the pressure, and its corresponding temperature also gets increased. Because of the increase in compression of air, pressure gets increased, as a result temperature also gets increased, and the incoming fuel as a result will involve in ignition. So incoming fuel should ignite below the compression temperature, which is what we call it as induction lag or delayed ignition. In the case of C10 rating or C10 number, or we can say in diesel based ICEs, ignition will be lagging behind, or we can call it as induction lag, or simply we will call that one as delayed ignition. In the case of petrol based ICEs, it is very fast, it is taking place very fastly. Okay, so that makes a difference between C10 rating and octane rating, that is petrol based ICE and diesel based ICE. Ignition it is a little lagging behind this one. Okay, so if you notice that locking characteristics of a fuel which is under examination, how it can be defined means, octane rating C10 rating, it is defined as a percentage of hexadecane, that is C10, in a mixture of N-hexadecane and 2-methyl naphthalene, which has the same ignition characteristics or locking properties, just like what you have studied in the case of petrol based ICEs for this diesel fuel which is under examination. Okay, so how it is defined? We have to consider the percentage of N-hexadecane, that is what we call as C10, in a mixture of N-hexadecane and 2-methyl naphthalene. So let us go with its structures. So this is the structure of 2-methyl naphthalene. 2-methyl naphthalene. This one it is structure of N-hexadecane. So if you notice the structure of 2-methyl naphthalene, so this is second position, a carbon second position which is having a methyl substitution, and it possesses C10 rating or C10 number that is equal to 0. So if it is for the case of N-hexadecane, as I told you, N represents straight chain linking, hexa means 6, hexadecane, so totally 16 carbons presence will be there. Here it is mentioned like methylene group, it is a 14, and this is 15, and this is 16. So total 16 carbons presence it is there, and it is having a common name that is called C10, or we will call it as N-hexadecane, and it possesses very good C10 rating or C10 number that is equal to 100. So as it is having more C10 number, that is 100, if its percentage it is more in fuel that you have considered under examination, then it will possess better anti-knocking properties. This is with respect to diesel based ICEs. Okay. So this is a tendency of the fuel constituents in order to involve in knocking process for diesel based ICEs. That order will be in this case. Aromatics it is greater than, branched alkanes it is greater than, alkenes it is greater than, naphthalenes it is greater than, and alkanes. So this is the order of preference, or we can say a tendency of the fuel constituents to involve in knocking in the case of diesel based ICs. Aromatics it is greater than, branched alkanes it is greater than, alkenes it is greater than, naphthalenes and it is greater than, and alkanes. Okay. So for improving this C10 number to the fuel sample, we need to add some kind of anti-knocking agents. So in this case, we are calling them as pre-ignition. Peroxide. If you notice the structure, ethyl nitrate, isoamyl nitrate, and then acetone peroxide. It is having dimer as well as trimer structures. Any of these can be added in proper proportions as pre-ignition dopes to the C10 number. So as I told you, what makes the difference between octane number and C10 number means octane number exists for petrol based ICs and C10 number exists for diesel based ICs. For octane number, pre-ignition will take place. For C10 number, delayed ignition will take place. Okay. And then examples and the tendency of the fuel constituents also so far we discussed. So finally we can conclude that hydrocarbons which are poor gasoline fuels like alkanes are quite good diesel fuels, and the reverse thing, that is vice versa. So that's all for today's class. In today's session, what we have discussed is its definition and better on anti-knocking reagents or better anti-knocking agents we have discussed. In this knocking, we have two different concepts. One is octane number. This will exist for petrol based ICs. Its example, and using that octane number 80, that is mixture of isooctane and n-heptane, that is 80:20 mixture, we have a clear idea about this octane number. This is purely due to pre-ignition. And the second one, it is C10 rating. The C10 rating or C10 number will exist for diesel based ICs. For this also we have a clear explanation about this concept using one example, that is N-hexadecanone, that is C10, and 2-methyl naphthalene. So that's all for today's class. Thank you so much. In the coming session, we are going to discuss about biodiesel, how it can be prepared, and what are its applications. All these things we will discuss in the next class.